Hello, welcome back to our series on LangChain4j framework. Today in this tutorial, we are going to see how we can get the JSON responses from the LLM with the help of LangChain4j chat model structured output. Structured output is a feature using which we can request the data from the LLM in a specific predictable format. For example, when integrating AI into our applications, we often want the data to be in specific format like JSON or XML so that it can be easily mapped to our existing Java classes. We are going to see 4 different ways how we can get the JSON data from the LLM. So starting with the first method, which is the simple prompting or the default text mode, wherein we will ask the model to produce the JSON output and we will specify this instruction within the system prompt or the user prompt. The problem with this approach is the output which is produced by the LLM might not meet our expectation, or it may contain certain additional text which makes the parsing very difficult. I'll showcase you one example. Here you will see the output which is produced by the model contains certain additional text like this. Also, it has added certain markdown. So such kind of output makes the parsing very difficult, due to which this method is one of the least reliable method, and it should only be used for the LLM models that does not have the native JSON support. Now coming to our second method, which is the JSON mode. In this case, we are going to work with the model that supports the structured output feature. Here we will ask the LLM to produce the JSON output, and LLM guarantees that the output produced by them will be a valid JSON, which means it will not contain any additional text or the markdown. Now there is one problem with this approach. Here we have not specified how our JSON output should look like, which means we have not given the JSON schema to the LLM, due to which the output produced by the LLM might not meet our expectation. It may contain certain additional field, or there might be some data type mismatch. For example, the numbers are represented in the form of string. Now coming to our next methods, which is 3 and 4. In this case also, we are going to work with the models that supports the structured output feature. The only additional thing that we will do here is, while requesting the LLM to produce the JSON output, we will also specify how our final JSON should look like, which means while sending the request to the LLM, we will also send the JSON schema to the LLM specifying this is the JSON we want. Now the difference between method 3 and method 4 is, since we have to send the JSON schema, first we will have to construct that. In case of method 3, we will make use of the classes that are available within the LangChain4j to construct the JSON schema. In case of method 4, we will make use of the existing JSON schema which is present in the form of string. So here is the summary of all 4 methods that we have seen. First one is the default text mode, wherein the output which is produced by the LLM might be difficult to parse. Then we have the JSON mode, in which the output will be a valid JSON, but still it might not meet our expectation because the output might contain certain additional fields or differences in the data types. Then we have the structured output, wherein the output produced by the LLM will be a valid JSON, and also it will match with the schema that we have shared with the LLM. Now, how we can request the LLM to produce the output in JSON format? So when it comes to the LangChain4j framework, if we have to interact with the LLM, we can make use of the ChatModel interface. So while creating the request object for the ChatModel interface, we can specify this information with the help of response format parameter. So we can set this parameter at 2 levels. First one is directly at the chat request level, and another one is within the chat request parameters. Now when it comes to the structured output, not all models support this feature, and if you are making use of the open router platform, this is how you can see which all model supports that. So for that, you need to visit to the models page of the open router platform, and then on the left hand side you will see the different filters. First you need to click on the supported parameters filter. Inside that you need to select the filter with name structured output. This will show all the model that supports the structured output feature. And if you have to see which free model support this, all you need to do is you need to type the keyword free. So this will show all the free model that supports the structured output feature. So for our demo purpose, we are going to make use of one such free model, which is the Mistral DevStral model. Now we are going to create a very simple application for demonstrating 4 different scenarios. So our application is going to be the Spring Boot based application, and the name of our application will be LangChain4j ChatModel Structured Output. In case of this simple application, we will simply request the LLM to produce some dummy e-commerce order details. So at the very top, we have the Spring Boot main class. Then we have the controller package containing the order controller. Inside this controller, we are going to create 4 different endpoints for demonstrating 4 different scenarios. Then we have the DTO package containing few Java records related to order details. So in this case, the output that will be produced by the AI will be mapped to these Java records. Then we have the application.yml inside the resources folder, which contains the basic configuration related to the LangChain4j. Then we have the pom.xml containing basic configuration related to our project. Now let's go through our code base, starting with the pom.xml. At the very top, you will notice we are making use of Spring Boot version 3.5.10. For Java, we are making use of version 21. And when it comes to the LangChain4j, we are making use of latest stable version, which is 1.10.0. Coming to the dependencies section, first we have added the Spring Boot starter web dependency. This will help us to create the REST APIs. Then we have added the LangChain4j OpenAI Spring Boot starter dependency. So if you are working with the OpenAI models, this dependency will be required. In our case, we are going to work with the free models that are offered by the Open Router platform, and these models are compatible with the OpenAI standards. That is why we have added the OpenAI specific dependency. Inside the dependency management section, we have added LangChain4j BOM for the version management. Now coming to the application YML, at the very top we have defined the name of our application. Then we are defining the configuration for our chat model with the help of the properties that are offered by the LangChain4j framework. So here you will see inside the LangChain4j OpenAI chat model, first we are setting the base URL. Since we are working with the Open Router platform, we have specified the base URL for that. Then we are specifying the API key. In our case, we need to specify the Open Router API key, and this will come via the environment variable, and the name of the environment variable is Open Router underscore API underscore key. Then we have defined the model name. In our case, we are going to work with the free model, and the name of our model is Mistral AI DevStral. Here we need to specify the model ID, and you will get it from the Open Router platform. And then for logging request and response, we have set the configuration to true. So this will be useful for debugging purposes. Now coming to our next class, which is the Spring Boot main class. This is the standard Spring Boot main class, which will bootstrap our application. Now before we go through a service class, I would like you to focus on the JSON which is shown on the right hand side. So this is the order details JSON which we want our AI to produce. For that, we need to define the JSON schema. This is where our schema builder service class will comes into the picture. And if you look at the JSON, at the root level we have certain fields. Then we have the nested object like shipping address, which has its own set of fields. Then we have the order items, which is the array of objects. And then we have the applied coupons, which is the array of strings. Now in order to define the JSON schema for this particular JSON, we will come to this class schema builder service class. Inside this class, we can define the JSON schema using 2 ways. First one, using the classes that are available within the LangChain4j framework. For that, we have this particular method get order schema. Another way of defining our JSON schema is using the string. For that, we have this method get raw schema string. Now we will go through our first method, which is the get order schema. So inside this method, you will see we are defining our schema with the help of different classes that are available within the LangChain4j. So in order to define the JSON schema, we are making use of JSON schema class. Then we are making use of the builder pattern. And then we are defining the structure that we want. So at the very root level, we are defining the JSON object. Since our JSON response is of type object, we are making use of JSON object schema. Inside this object, first we have defined the three fields like order ID, total amount, and is gift wrapped. For that, we are making use of add property method. We have defined the name of our fields. Then we have defined the type for these fields. For example, for our order ID, the type is JSON string. Here you will see the values of type string. For amount, the values of type number. We are making use of JSON number schema. For is gift wrap, the type is boolean. For that, we are making use of JSON boolean schema. And then with the help of builder pattern, we are defining that. And for each field, we are giving the optional description like unique order identifier, total cost of the order, and so on. Then we have the nested object, which is the shipping address. It is of type object. So we have defined the object with type JSON object schema. Then we have these nested fields like street, city, and zip code. Here you will see we have defined the street, city, and zip code. First two are of type string. Third one is of type integer. We have specified that. And here we have specified these fields as required, which means whenever LLM will produce the output, it should always contains these three fields inside the shipping address object. Then we have defined the array of objects for order items. And in order to define the array, we have the JSON array schema. And then inside the array, we need to specify our items. And each item is of type JSON object. We are making use of JSON object schema. Then we are defining the properties like product name, quantity, price, and so on. We have defined the type for the same. And we have specified all these three properties as required. Then we have the array of string for applied coupons. So here you will see we are making use of JSON array schema. And inside the items, we are specifying the JSON string schema with the optional description of coupon code. Now, in order to define the mandatory fields at the root level, we are making use of dot required, within which we have defined all the fields as mandatory like order ID, total amount, is gift wrap, shipping address, order items, and so on. And finally, we are calling the build method, which will give the object of type JSON schema. So this is how we can define the JSON schema with the help of classes that are available within the LangChain4j framework. Now another way of defining schema is using the string. For that we have this method get raw schema string. If we expand this method, here you will see the entire JSON schema is defined within the string itself. Here you will see the type is of type object. Then we have the properties. We have defined our nested object. And also we have specified the required fields. Here we are making use of one additional property named as additional properties as false, which means apart from these fields, LLM should not add any additional fields when it comes to the shipping address. So here you will see additional properties defined within the shipping address. Inside the shipping address, it won't add any additional fields apart from these three fields. Similarly, we have defined the order items and then we have defined the applied coupons. And at the end, we have specified all the fields that are required at the root level. And similarly, we have mentioned we don't want any additional field, due to which we have set the additional properties as false. So these are the two ways using which we can define our JSON schema. Now this particular JSON schema will be used while we will go through our controller class. Now coming to our DTO package, here we have defined few Java records for the order details. So the output that will be produced by AI will be mapped here. So if we see the order details, this particular structure will map with the JSON that we have seen just now. It has fields like order ID, is gift wrapped, nested objects like address, list of order items, and so on. For address, we have this particular Java record, and for defining order item, we have this particular Java record. Now coming to our controller package, we have the order controller class. Inside this class, we are going to create 4 different endpoints for showcasing our 4 different scenarios. Now let's go through this order controller class. At the very top, we have defined the base path for our endpoints, which is /API/order. Then we have defined the chat model, schema builder service, and the object mapper. all these threes are getting initialized with the help of constructor injection. So here you will see all three are getting initialized. And then we have defined the 4 different endpoints for our 4 different scenarios. First one is the get text order, which is the get type of endpoint with path suffix as /text. In this case, we are going to work with the models that does not have the native JSON support. Then we have the get generic order endpoint, which is also a get type of endpoint with path suffix as /generic. In this case, we are going to work with the models that supports the structured output feature, but we are not going to specify our JSON schema in this particular case. And then we have the get structured order endpoint, which is a get type of endpoint with path suffix as /structured. In this case also, we are going to work with the models that supports the structured output feature. And while sending the request to the LLM, we will also specify our JSON schema stating this is how we want our final JSON to look like. And the JSON schema that we have defined inside the schema builder service class will be used here. Similarly, we have the get order by raw schema endpoint, which is a get type of endpoint with path suffix as /raw schema. In this case also, we will send our JSON schema to the LLM, which we have defined inside the schema builder service class. Now let's go through each of these methods in very detail, starting with the get text order. So if we expand this method, here you will see at the very top we are defining the user prompt with the help of user message class. So here we are defining the prompt as generate a sample order receipt in JSON format. Once we have the user message, we need to specify it inside the request object. And in order to create the request object, we are making use of the chat request class with the help of builder method. First, we are defining the messages. Since we only have user message, we have specified it here. Then we are defining the format in which we want our output. For that, we have the response format. And in order to define a response format, we are making use of the builder pattern. Then we are defining the type as text, which is the response format type.text. And once we have defined the response format, we are simply calling the build method, which will give the object of chat request. Now we have the request, we need to send it to the LLM. We will do that with the help of ChatModel. So here you will see we are calling the ChatModel.chat method. We are specifying our request object, which will give us the chat response, which is nothing but the output which is produced by the LLM. And from this response object, we are extracting the text which is produced by our LLM. Once we have the text, we are simply returning the string response back to our customer. So this is the first endpoint. Now coming to our second endpoint, which is get generic order. Here also you will see first we are defining the prompt for our LLM stating generate a fake e-commerce order receipt. We are creating the user message, and you will notice in this particular case we have not defined that we need the output in the JSON format. Once we have the user message, we need to specify it inside the chat request. For that, we are making our chat request builder. Then we are specifying our user message, and then we are specifying the response format stating we want the response output in the form of JSON. So we are doing that with the help of response format.builder.type containing the response format type as JSON. And then we are calling the build method, which will give the chat request object. And with the help of ChatModel, we are interacting with the LLM by passing our chat request object. Once LLM has processed our request, it will return the output in the form of chat response object. Inside this chat response object, we will have our AI response. So we will extract that by calling response.ai-message.text. Now this particular output is in the form of string. We need to convert it to the JSON so that we can send it back to the end user. For that, we are making use of the object mapper.readValue method, within which we have defined the output which is produced by the JSON, and then we have defined the type reference. So here you will see the final output that will be sent to the user will be in this particular form, which is map of string of object. Now coming to our third endpoint, which is the get structured output. Here also the overall flow is going to remain same. First we will create the user prompt stating create a complex order with 2 items and the shipping address, and then we will specify it inside the chat request object. Then we will specify the response format stating we want the output in the form of JSON. And then we are also specifying the JSON schema, stating this is how our final JSON should look like. And if you remember, we have defined the JSON schema inside this class, schema builder service class. So we are making use of that schema builder dot get order schema. Inside this method, you will see we have defined the JSON schema with the help of classes that are available within the LangChain4j framework. And then finally, we are calling the build method, which will give the chat request object. Once we have the chat request object, we are interacting with the LLM with the help of ChatModel. Once the request has been processed, this will give the chat response object as the output. And within this, first we will extract the JSON output which is produced by the LLM in the form of string. So this is how we are extracting the same by calling the AI message.text. Now we need to convert this JSON output in the form of order details Java record that we have defined here. So for that, we are making use of the object mapper dot read value, which will map the JSON output which is produced by the LLM in the form of string into this particular Java record, which is the order details. Once this has been mapped to the order details object, finally we are returning it back to the user. Now coming to our final endpoint, which is get order by raw schema. Here also the overall flow will remain the same, but we will have to perform one additional step of converting the string JSON schema to the JSON schema Java object. So at the very top, we have defined the prompt as generate a fast shipping order for mechanical keyboard. And then we are performing the process of converting the JSON schema in the form of string to the JSON schema object. So first we are reading the string JSON schema by calling the schema builder service class dot get raw schema method. So if we open this method, here you will see the schema is defined in the form of string. And then we are storing it inside the variable. And using this variable, we are creating the JSON raw schema by calling JSON raw schema dot from by passing the string. And then we are converting the JSON raw schema to the JSON schema with the help of builder pattern. Here you will see first we have given the name, then inside the root element we are passing our JSON raw schema and then calling the build method which will give the JSON schema. Now we have the user message, we have the JSON schema, we need to call it to the LLM by passing the chat request object. So here you will see we are creating the chat request object by passing the message. Then we are specifying we need the output in the JSON format, and then we are specifying our JSON schema by passing the JSON schema object that we have created here. And then we are finally calling the build method which will give the chat request object. And then we are calling the LLM with the help of ChatModel. Once the LLM has processed our request, it will give the output in the form of chat response. Inside this chat response, the JSON output which will be produced by the LLM will be in the form of string. We are extracting it here by calling response.ai-message.text. And then we are converting this JSON string into the order details Java record with the help of object mapper. So here you will see we are calling the object mapper.read value, which will convert the JSON string into the order details format. And finally, we are returning the order details back to the user. So yeah, this is how we can produce the structured output using LangChain4j chat model. Now we will test our application. For that, we need to start our application. And while starting our application, we need to pass our open router API key under this environment variable open router API underscore key. Yeah, our application is started. Now we will test all our 4 endpoints. Now we will test our first endpoint, which is the slash text endpoint. In this case, we are going to work with the model that does not have the native JSON support. And here we are saying that generate a sample order received in the JSON format. And if we go to the application.yml, I have changed the model to the DeepSeek R1 model, which does not have the native JSON support. Now when we will send the request, we should see the response in the JSON format, but it might also contain certain prefix text or the markdown. So yeah, here you will see we have received the JSON response, but apart from JSON response, we have also received certain additional text which might makes the parsing very difficult. So this is the JSON we have received from the DeepSeek R1 model. Also, we have certain additional text after the JSON response. Yeah, now for testing the rest of the three endpoints, we are going to work with the model that supports the structured output. So in our case, we are working with Mistral AI DevStral model, and I have restarted our application. So now we will test our second endpoint, which is the slash generic. In this case, we have given the prompt as generate a fake e-commerce order receipt, and we have not specified the JSON schema. So whatever JSON output which is given by the AI, we will simply return it back to the user in the form of map of string of object. Now we will send the request to the generic endpoint, which is API order generic endpoint, and we should see some valid JSON from the LLM. So yeah, we have received the response from the LLM, and here you will see the response which is given by the LLM is a valid JSON. It does not have any prefix or suffix text. Yeah, now we are going to test our third endpoint, which is the slash structured endpoint. In this case, we are asking the LLM to create a complex order with 2 items and a shipping address. And also we have specified our own JSON schema. So the output that will be produced by the LLM should be in the form of JSON. Also, it should match the JSON schema that we have provided to the LLM. For this, we will send the request to the API order structured endpoint, and we should see the valid JSON as the output. So yeah, we have received the response from the LLM, and here you will see we have received the valid JSON. Also, the structure is matching with the JSON schema which we have provided to the LLM while sending the request. So here you will see it has the three fields at the root level. It has the nested object, array of object, and the array of string. This is something same we have defined inside the service class. Here you will see we have the order details root object. We have three fields like order ID, total is gift wrap, shipping address as the nested object, order items, and the applied coupons. So this is also working as expected, and all the required fields that we have mentioned are also present here, and it does not contain any additional fields. Yeah, so now we will test our final endpoint, which is the raw schema. Here also we are asking the LLM to produce the JSON output, and also we are specifying the JSON schema which was defined inside the string, and the prompt which we have given is generate a fast shipping order for mechanical keyboard. Now when we will send the request to the raw schema endpoint, we should see a valid JSON, and also the structure should match with the JSON schema that we have defined inside the service class. So here you will see we have received the response. The response is a valid JSON. Also it is matching with the structure that we have defined inside the service class. For example, if we go to the service class method, here you will see we have defined the JSON schema containing order ID, total amount, shipping address, order item. It is matching order ID, total amount, shipping address, and order items. Also, it contains all the required fields that were defined inside this, like street, city, and zip code should be present inside shipping address. So street, city, and zip code are present. Also, we have given additional properties as false, which means while producing the output, it will not add any additional fields, which is also true. So this is how our endpoint is working as expected. Now I would like to showcase you something. While we are requesting the JSON data from the LLM, in that case, what all additional parameters or values that are getting sent to the LLM. So consider the example of this particular endpoint slash raw schema endpoint. When we send the request, this is how the overall request was sent to the LLM. So here you will see the request was sent to the open router platform chat completion endpoint. This is the model name. This is the prompt that we have defined inside our method. And in order to generate the JSON output, this is the additional info that was sent inside the response format. Here you will see the type is JSON schema, and the JSON schema that was defined in the form of string is sent to the LLM. So this is how the overall request was sent to the LLM containing our entire JSON schema that we have defined. Another example is of the slash generic endpoint, wherein we were only requesting the JSON output from the LLM, but we didn't specify our JSON schema. So this is how the logs will look in this particular case. So here you will notice the request was sent to the open router platform. The model name is mentioned here. The prompt is mentioned here. And inside the response format, only the type is mentioned as JSON object, and since we didn't specify any of our JSON schema, due to which that particular information is not present here. Yeah, so that was all regarding how we can get the JSON responses from the LLM with the help of ChatModel structured output. For this, we have also written one detailed article which you can go through if you are interested. Also, the code base that we have seen in this tutorial is uploaded on GitHub. You can simply check out the code, set your Open Router API key and test the same. Yeah, so that was all from my end. I hope you found it useful. Thank you.